There's never a good place to start a cybersecurity story. Technologies grow almost like organisms do. Early, small decisions have reverberating impact as the technology matures, just like small changes in DNA impact organic evolution. And this is particularly true of cyber resilience. The ability to protect, detect, and recover from attacks necessitates the ability to look into the future at what new threats you will have to address, and address them today using the technology you bought yesterday. Cyber resilience, then, requires us to be able to adapt our cybersecurity measures, the way our early ancestors had to adapt to changing environments, rapidly, and without always being sure how the decisions we're making today will impact our capabilities tomorrow. Here's an example of what I mean. We'll start in the middle of the story of cybersecurity in 2011. Earlier industry efforts to protect the BIOS have been successful, culminating in the publication of NIST's BIOS protection standards, SP 800-147. NIST developed the BIOS protection standard collaboratively with platform manufacturers, chip manufacturers, and OS vendors. But experts agree there were still gaps worth addressing, like protecting firmware outside of the BIOS and creating the ability to recover automatically, preventing DOS attacks. So NIST convened industry experts to create a framework for protecting firmware on a wide variety of platforms. And this group drew on existing industry practice for securing firmware updates and facilitating recovery for corrupted firmware to create a framework for designing systems resilient to attacks on low-level code that would leave the system inoperable. This resulted in NIST publishing NIST SP 800-193, the Platform Resilience Standard. But what's most interesting is that the Platform Resilience Standard is itself resilient. And what I mean by that is folks have taken it and built on it, evolved it to address new use cases. It's been implemented in servers, in network equipment. Others are applying it to Internet of Things devices. And now there's new work to extend firmware resilience to 5G systems. So NIST Platform Resilience Standard is a great example of a resilience standard that was developed in a resilient manner. It was able to adapt and change the use cases it was addressing. Its development was moved along by a shifting mix of participants, each addressing their own unique requirements. It had early implementation by vendors. Governments encourage use of standards-based approaches that address the agreed-upon requirements. And it spawned smaller, agile efforts to drive specific implementation details in communities of interest. I'm Jessica Fitzgerald-McKay. I'm the co-lead for NSA's Center for Cybersecurity Standards. I'm here today with my co-lead, Mike Boyle. And in this talk, we'll study how the manner in which a standard is developed adds to its implementability, its ability to evolve to meet new use cases, and its ability to meet past and current threats. In other words, we'll discuss what makes standards development processes resilient. But before we do that, what is resilience? There's lots of kinds of resilience. There's psychological resilience, a person's ability to respond to hardship. There's organizational resilience, an organization's ability to grow and change. And this usually relies on the diversity of thought and experience and interest of the groups in the organization, and how the organization helps their people to develop and to explore and to grow. And there's cybersecurity resilience. This is resilience from a technological security point of view. A system is under attack from an adversary. How can we protect against that attack, detect the attack, and recover from the attack? All of these aspects of resilience matter, especially in a pandemic, but we're going to be focusing on the last one, within the context of how organizational resilience impacts the resilience standards. It's important to pay attention to the psychological aspect, though. It's always lurking in the details. So we'll explore a little bit of each of these in our talk. We can think of these forms of resilience as a hierarchy. The people that make up an organization have to have a certain amount of psychological resilience to perform well at their jobs. And cyber resilience relies on organizations, especially vendors in the cybersecurity industry, to create the products that provide protection, detection, and response capabilities. Because different solutions might be needed for protection, detection, and response, these products have to interoperate. And to do that, we'll need resilience-focused standards. Thus, standards development organizations and their organizational resilience becomes important to cyber resilience efforts. This talk is focused on the role that standards play in creating resilient products and systems. Certain approaches to developing those standards lead to more usable and resilient outcomes. In the end, a good mix of customers, not just a few, but ones with a diversity of needs and implementers, is critical to solving the problem. The structural process within a standards development organization, especially pertaining to the cost of participation, how the group makes decisions, and who members in the group represent, all contribute to the diversity of the group. The benefits of standards are many. This set listed here all add to the resilience of a solution. And each is important to the resilience of national security systems, which is the reason NSA is engaged in standards. Mike and I are the leads for NSA Center for Cybersecurity Standards. We established the center last year to make NSA's Cybersecurity Directorate a more effective participant in standards development. As a customer of standards, we have a keen interest in developing standards that meet our requirements to protect national security systems, as well as a mandate to see implementation and adoption across national security systems. And we get to draw on a large pool of amazing technical experts from across NSA to address critical security problems through those standards. In this work, we get to participate in a wide variety of standards development organizations. Each has its own culture, its own mode of operation and business rules. We've isolated 4 structural or cultural variables that influence the effectiveness of the standards produced by a standards development organization. And you have to note here, different combinations of these variables can be more or less effective depending on the task at hand. For example, is the group trying to develop a quick technical solution? Are they trying to standardize a best current practice? They're trying to create a solution that be used broadly and touch many people directly. Each of these might require a different mix of these 4 structural variables to get the job done. The first factor to consider is openness. Are there barriers to participation? Do you have to pay to join? How high is the fee to attend the meetings? How much work takes place face-to-face versus virtually? This is especially important these days, but meeting attendance is a continual blocker, even in non-pandemic times for a lot of organizations and individuals. The second factor is types of membership. Who has a voice in the standards development organization? Do the participants represent their country, their organization, or themselves as an individual? The third factor is how decisions are made. Does everyone have to agree? Are there votes? Who gets a vote? Are there different answers depending on the topic or the stage of standards development? And your instinct here might be that full agreement by all members is preferable, but there are pros and cons here. If you need everyone to agree, one holdout can keep something from happening. And the final factor we consider is mix of voices. Do the customers have a voice? Do the implementers have a say as well? Does the SDO encourage, or sometimes even insist on, interoperable implementations before a standard is complete? Who even is the customer? Is it an end user, a procurement office, an auditor? Can it even be another vendor building a more complex system? The range here develops applicability of the standard. Customers can dream up a lot of great, but not very implementable features. And implementers don't often have a full understanding of how a feature will be used in the real world, or how it can work with other systems in a customer's network. With those factors in mind, let's consider some examples of standards development and how the outcomes were influenced by the standards development organization's culture. I'll hand off to my colleague, Mike, so he can apply these factors to some case studies of resilient standards development.
Thanks, Jess. I'm going to talk about 3 examples of standards development efforts that support resilient network operations. We chose these examples because of our engagement in the standards efforts. We got to see the standard being developed as well as the end product. Each of these standards is important to our standards center strategy for securing national security systems. So our first example involves the Trusted Computing Group. The TCG is a vendor consortium with a small list of initial goals, primarily focused on protecting or measuring the BIOS on commercial devices. One of their cornerstone technologies is the Trusted Platform Module, or TPM. As the diagram shows, the TPM uses several cryptographic functions and protected storage locations to take measurements on the platform and report on the state of BIOS and firmware. This allows the TPM to serve as a safe place to stand and support a platform resilience. There was little customer input initially. Mostly the participants were vendors who would provide parts of the solution. This benefited the work in the SDO in the short term, as it was a way for the small number of TPM manufacturers, the small number of operating system owners, and the small number of major platform vendors to collaborate quickly and efficiently. But the downside was there was slow initial uptake. There was a lack of applications. There was a cycle of a major operating system release that was missed, and there was slow adoption because of that. For a while, the TPM was widely available on commercial platforms, but very little used. BitLocker was an early and popular application, but there were not a lot of other features that an end user could leverage. So we felt that it would help drive adoption to share the TPM measurements with other network applications. Toward that end, we participated in developing the architecture for reporting, which is designed to collect posture information from endpoints, either when they join the network or periodically while they're connected. Assess that information and determine whether it is aligned with the policy of the network in order to make decisions on whether the endpoint may remain connected. Information that's collected for the assessment can be leveraged to mitigate vulnerabilities and target patching of software that may be vulnerable. When these health reports were rooted in a TPM, this was known as attestation. There was always interest within TCG in hardware support for attestation to increase trust, but not a lot of adoption. The architecture had very little uptake, and eventually most of the workgroup members left the effort. Ultimately, it turned out that attestation was very hard to implement in a way that made customers' lives easier. Because it was difficult, there was little demand, and therefore no real profit in implementing it. So when we look at the mix of voices in the TCG, the work is very vendor-driven. Member companies can join at various levels with varying financial commitments, and they're able to vote in workgroup meetings. The board of directors is drawn from these member companies. They are very open to liaison members, such as the US government. The liaison members don't vote or sit on the board, but we have never experienced issues participating actively and contributing to TCG work. Possibly due to that vendor focus, TCG as an organization is not focused on the implementation of their standards. That work is left to the member companies. Standardization is focused on the interaction between TCG components and the rest of the system. Now let's assess the culture of TCG with respect to the 4 factors that Jess identified. There is a membership fee, but governments and academic organizations can join for free as liaison non-voting members. Membership is per company or similar organization. Votes are held and majority rules. There are many more vendors than customers. To sum all that up, TCG standards development can be agile. They don't require consensus. Vendors are mostly focused on developing standards that will create an ecosystem they can sell into. Lack of customer input is partially responsible for slow adoption. The current state of TCG is that they've realized the difficulty in implementing TPM-based solutions, and they've worked hard to make them easier to use. Today, TPMs are widely available and are starting to be used more within emerging applications. And we'll explore some of these new applications next. So while the Trusted Computing Group was developing the TPM, other groups like the FIDO Alliance or Android developers had developed mechanisms for attesting the state of a platform. The Internet Engineering Task Force, Remote Attestation Procedures, and they call it RATS. You'll have to work with us to see that acronym in those words, was formed to standardize claims and evidence about the system in a technologically agnostic way. This work is critical to spurring a marketplace of solutions that leverage attestation. Because it's technology agnostic, it requires a venue with a broader set of vendors, not all trying to use the same technology. It also benefits from customer participation, recognizing that data formats must support information that solves real-world problems. The ability to attest to the state of diverse platforms is crucial to achieving resilience at a network level. IETF has a strong requirement for interoperable implementations or running code. Within RATS, this has resulted in a broad view of what can be attested, and participants have worked together to abstract the attestation architecture in a way that allows for maximum flexibility. The components of the architecture can be implemented in a number of configurations. This diagram is just an example of one of those. And the functions can reside on any type of device, either physical or virtual. This maximizes the ability of the architecture to be applied to new and emerging use cases, as we will see shortly in use case 3. So how does IETF measure up to our 4 cultural factors? Well, IETF is open. There's no cost to participate. Attendance at meetings costs money, but all business is done on mailing lists that anyone can freely join. Membership is per individual. Famously, IETF operates by rough consensus and running code. This means that no one voice can push a standard through, and no one voice can halt a standard. The group must come to a reasonable agreement and need to demonstrate that the agreement works with the code they've written, but work can progress. There's a good mix of participation leaning toward vendors somewhat. Because of their focus on consensus and the diversity of voices participating in their work, IETF has a good track record for adoption. So one of the emerging use cases for the RATS architecture is in 5G networks. 3GPP is the SDO where standards have been developed for 3G, 4G, and now 5G. The Standards Center is working within 3GPP to leverage the RATS architecture for remote attestation within 5G networks. There's a lot in this slide. We're using it to drive our attestation work in 3GPP, and there is some complexity. The slide shows IoT devices attesting their health to the network data analytics function. This will allow the analytics function to make connectivity decisions based on the device's attested health status, which could include device ownership, update status, configuration status, and other things. The analytics function can share this information with data repositories used for network reporting, as well as orchestration and management services that make decisions about network bandwidth, slicing, etc. Most interestingly, though, this data can be shared with other analytics functions. These functions drive machine learning and artificial intelligence on the network. AI ML functions require good, well-formed, trustworthy data to build models that accurately reflect the state of the network in order to automate protection of that network. Attestation can be used to ensure that machine learning processes are not poisoned or biased by malicious devices. Notice how these case studies have built upon each other and how resilience has moved up the stack from platforms to network operations. Now, to assess the culture of 3GPP. 3GPP has membership fees, and it's structured by organizational membership. It drives toward consensus for technical studies, but majority voting is used to choose work group leaders. So there's a mix there in decision-making. Membership is biased toward vendors, but with significant input and participation from customers. This is perfect for a new technology like 5G. Vendor voice is necessary for implementability, but customer voices are necessary for adoption and use. What we've seen from these examples is that the culture of an SDO matters in the development of a standard. Smaller groups can create a standard quickly, but it usually takes a group with a greater diversity of perspectives to create a useful standard that is fit for a wide variety of use cases and to evolve existing standards to meet new cybersecurity challenges. Now I'll hand back to Jess so she can talk about how we apply the lessons learned from these examples to future standards work.
Mike demonstrated how important it is to consider the openness, types of membership, decision-making processes, and the mix of voices in a standards development organization when developing a resilient standard. Having the right mix helps to support complex use cases that require participants to be able to cooperate widely. We can't lose sight, though, of all the other ways we can build diversity of thought into the standards development process. We need to be sure that the greatest number of voices are heard in the standards development process, that the process isn't dominated by the most powerful contributors, and that customers of the standards are considered integral to the process. Those customers often bring a diverse set of requirements based on the environments they're trying to operate in. For instance, rural or developing areas may have needs that are quite different from cities with an existing IT infrastructure, particularly with telecom standards. And those kinds of requirements need to be considered. 2020 was a year where we all leaned hard on new technologies to get our work done. Virtual meetings became a way of life. Our children adapted to learning from home, and our ability to access data from anywhere became absolutely critical. And by and large, those technologies met the challenge, the occasional frozen coworker on a virtual meeting notwithstanding. But there's surely work to be done to make those technologies even more secure and even more resilient, and standards will play an important role. Over time, customers will require greater protection of their data that's stored and shared in the cloud. and new life-critical applications, like those in the health sector vertical, will demand systems that are highly responsive and guarantee many nines of uptime. Looking even further forward, decisions are being made today that are setting the course for future wireless networks. And those decisions will determine which applications, like telemedicine, autonomous vehicles, enhanced virtual reality, are optimized for 6G networks. The important question to ask is, which stakeholders, be it countries, vendors, and users, are being represented in the process? Using the model we described here today can help us get ready to engage in setting these requirements. Today, the International Telecommunication Union Standards Workgroup, the ITU-T, is the driving body for 6G requirements. Participation in the ITU-T is through a country, yours or the one you do business in. There are fees involved. Decisions are made by voting. One country gets one vote. And participation is decidedly skewed to customers. The lack of vendor participation could really impact their solutions. As we've seen here today, for implementability and adoptability, a standards development organization needs an appropriate mix of vendors and customers. To get the right mix of voices from customers, cost and consensus are preferred. Work in the ITU-T will likely not provide that mix, and this could slow down work on 6G systems, causing them to not meet customer needs, not be able to be implemented by vendors easily. Based on our evaluation of resilient standards development, we recommend that groups like 3GPP and IETF take a larger role in setting 6G network requirements. But this slide is really how we, Mike and I, are applying what we learned as a result of our analysis of resilient standards development organizations. What would we recommend you do with this information? Starting next week, we hope maybe you'll be able to begin thinking locally. How can you increase the diversity of thought in your organization? More importantly, how can you ensure that that diversity of opinions are considered? And think about cyber resilience in your organization. What are your critical cannot fail systems, and how are you protecting them? How are you detecting threats against them and responding to those threats? Over the next 3 months, we'd like you to start regarding cyber resilience standards we've been discussing. We'd love to hear your feedback. Particularly in terms of the applicability to your organization's problems. It's kind of like a natural life cycle to standards, and there's a really great chance that each of these technologies will someday be reopened in some form for improvement. Think now about what's missing. More generally, what are the problems you and your organization faces which are not being addressed resiliently by these standards? Within 6 months, we hope you'll get involved in these and similar organizations' standards efforts. Expanding the range of ideas considered in developing standards such as these benefits us all. Think about your 6G requirements for your network. What would you like to see supported? And work within relevant standards bodies to contribute those requirements and make your voice heard. And of course, we'd love to hear from you to get feedback on the standards we talked about here today. Please reach out to Mike and I. You can reach us at cs_standards@cyber.nsa.gov. We look forward to hearing from you.